According to the National Electrical Code, electrical receptacles must be installed at heights between 12 and 18 inches above the floor. However, there is an exception for ranges. Receptacles for ranges may be mounted lower than 12 inches but not lower than 4 inches above the floor. You can use a 3-wire cable to bring a hot and 2 switch legs to a switch-over switch. The third wire in the cable will be used as the neutral. The wiring configuration for a switch-over switch with a 3-wire cable is as follows. Firstly, connect the hot wire from the circuit breaker to the common terminal on the switch. Secondly, connect one switch leg to the normally open terminal on the switch. Thirdly, connect the other switch leg to the normally closed terminal on the switch. Fourthly, connect the neutral wire from the circuit breaker to the neutral terminal on both switches. Finally, connect the light and fan to the terminals on the switches as indicated on the switch diagrams. Always follow proper electrical safety precautions when working on electrical systems. Check with the local building inspector for any specific requirements or restrictions. Ensure that all electrical work meets the requirements of the NEC and any applicable local codes. I will now elaborate on the National Electrical Code, specifically focusing on the requirements and guidelines related to range receptacles and the use of 3-wire cables for switch configurations. Let's delve deeper into the specifics of range receptacle height requirements as outlined by the NEC. While general receptacle height is mandated to be between 12 and 18 inches above the finished floor, the NEC recognizes the unique requirements for range receptacles. Due to the physical design of electric ranges, which often have a minimal clearance between their base and the floor, the NEC permits a low mounting height for range receptacles. Specifically, range receptacles can be installed lower than the standard 12 inches, but they must be no lower than 4 inches above the finished floor. This exception is intended to ensure that the range can be installed close to the wall without the receptacle interfering with its placement. The 4-inch minimum height is crucial for safety and accessibility, preventing the receptacle from being too close to the floor where it could be easily damaged or become a hazard. When installing range receptacles, it is imperative to adhere to these height requirements to maintain code compliance and ensure the safe operation of the appliance. It's also important to verify the specific requirements of your local building codes, as they may have additional restrictions or amendments to the NEC guidelines. Now, let's explore the use of 3-wire cables for switch-over-switch configurations. A 3-wire cable consisting of a hot wire, a neutral wire, and a switch leg can be utilized to control a light and a small bath fan using a switch-over-switch setup. In this configuration, the hot wire from the circuit breaker provides the power source. One switch leg is connected to the normally open terminal of the switch, while the other switch leg is connected to the normally closed terminal. The neutral wire from the circuit breaker serves as the return path for the current in both the light and the fan circuits. This wiring arrangement allows you to control both the light and the fan independently using the switch-over-switch configuration. For example, flipping the switch to one position may activate the light, while flipping it to the other position activates the fan. The third position, typically the center position, may turn off both the light and the fan. It is essential to follow the correct wiring configuration to ensure the proper functioning of the switch-over-switch setup and to prevent any electrical hazards. Always refer to the switch diagrams and the manufacturer's instructions to ensure that you are connecting the wires correctly. It's crucial to emphasize the importance of safety when working with electrical systems. Always energize the circuit by turning off the circuit breaker before starting any electrical work. Use appropriate personal protective equipment, such as insulated gloves and safety glasses, to protect yourself from electrical shock and other hazards. Double-check all connections to ensure they are tight and secure, and that there are no exposed wires or loose terminals. If you are unsure about any aspect of the electrical work, it's always best to consult with a qualified electrician. They can provide guidance and assistance to ensure that the work is done safely and correctly. Additionally, always remember to check with your local building inspector for any specific requirements or restrictions that may apply to your electrical work. Local codes may have additional regulations or amendments to the NEC guidelines, and it's essential to comply with these requirements to avoid any violations. Finally, ensure that all electrical work meets the requirements of the NEC and any applicable local codes. This includes using the correct wiring methods, installing the proper overcurrent protection, and ensuring that all electrical components are properly grounded. By following these guidelines and taking the necessary precautions, you can ensure that your electrical work is safe, code compliant, and reliable. Let's continue to elaborate on the technical aspects of electrical installations, focusing on the application of the National Electrical Code in practical scenarios. The NEC serves as a comprehensive standard for electrical safety, providing detailed requirements for various aspects of electrical systems, from wiring methods to equipment installation. Adhering to the NEC is crucial for ensuring the safety of people and property, and it's the responsibility of all electricians and electrical contractors to be familiar with and follow its guidelines. When dealing with range receptacles, the NEC specifies not only the height requirements but also the type of receptacle that must be used. Typically, a 50 amp receptacle is required for electric ranges, and it must be properly grounded to ensure safety. The grounding conductor provides a path for fault current to return to the source, tripping the circuit breaker and preventing electrical shock hazards. It's important to use the correct size and type of wire for the range circuit, as specified by the NEC. The wire must be capable of carrying the maximum current that the range is expected to draw, and it must be protected by a circuit breaker of the appropriate size. Using undersized wire or an oversized circuit breaker can create a fire hazard. Furthermore, the NEC provides detailed guidelines for the installation of electrical boxes, including the size and type of box that must be used for different applications. The electrical box serves as a protective enclosure for the wiring connections, preventing them from being exposed to physical damage or moisture. It's important to choose the correct size of box to ensure that there is enough space for the wires and connections, and to avoid overcrowding the box. The NEC also addresses the issue of conductor fill, which refers to the maximum number of wires that can be installed in an electrical box. Overfilling a box can create a fire hazard by causing the wires to overheat. Therefore, it's essential to follow the NEC guidelines for conductor fill to ensure that the electrical system is safe and reliable. In addition to the requirements for range receptacles and electrical boxes, the NEC also provides detailed guidelines for the installation of lighting fixtures, switches, and other electrical equipment. These guidelines cover a wide range of topics, including the mounting height of lighting fixtures, the type of wiring that must be used for different applications, and the grounding requirements for electrical equipment. By following the NEC guidelines, electricians can ensure that electrical systems are installed safely and correctly, minimizing the risk of electrical hazards. Moreover, the NEC is not a static document. It is updated every 3 years to reflect changes in technology and best practices. It's important for electricians to stay up to date with the latest edition of the NEC to ensure that they are following the most current guidelines. Continuing education courses and professional development opportunities can help electricians stay informed about the latest changes to the NEC. Finally, it's essential to remember that the NEC is not a substitute for good workmanship and common sense. Electricians must use their skills and knowledge to ensure that electrical systems are installed safely and reliably, even when the NEC does not provide specific guidance. By combining a thorough understanding of the NEC with good workmanship and common sense, electricians can create electrical systems that are safe, efficient, and code compliant. I will now expand on the practical aspects of wiring configurations, focusing on the nuances of switch installations and the considerations for different types of circuits. When dealing with switch installations, it's crucial to understand the different types of switches and their intended applications. Single-pole switches are the most common type of switch, and they are used to control a single light or appliance from a single location. Three-way switches, on the other hand, are used to control a single light or appliance from 2 different locations. Four-way switches are used in conjunction with three-way switches to control a single light or appliance from 3 or more locations. The wiring configuration for each type of switch is different, and it's essential to follow the correct wiring diagram to ensure that the switch functions properly. When wiring a single-pole switch, A hot wire from the circuit breaker is connected to one terminal on the switch, and the other terminal is connected to the light or appliance. The neutral wire is connected directly to the light or appliance. When wiring a three-way switch, the hot wire from the circuit breaker is connected to the common terminal on one of the three-way switches. Two traveler wires are connected between the two three-way switches, and the light or appliance is connected to the common terminal on the other three-way switch. When wiring a four-way switch, the traveler wires from the three-way switches are connected to the four terminals on the four-way switch. The four-way switch essentially swaps the traveler wires, allowing the light or appliance to be controlled from multiple locations. In addition to understanding the wiring configurations for different types of switches, it's also important to consider the type of circuit that you are working with. Branch circuits are the most common type of circuit, and they are used to supply power to lighting, receptacles, and small appliances. Appliance circuits are used to supply power to large appliances such as refrigerators, ranges, and dishwashers. Dedicated circuits are used to supply power to specific equipment such as computers or medical devices. The NEC provides specific requirements for each type of circuit, including the size of the wire that must be used, the type of overcurrent protection that must be provided, and the grounding requirements. When installing a branch circuit, it's important to calculate the load that the circuit will be expected to carry. The load is the total amount of current that the appliances and equipment connected to the circuit will draw. The NEC provides guidelines for calculating the load for different types of appliances and equipment. Once the load has been calculated, the appropriate size of wire and overcurrent protection can be determined. When installing an appliance circuit, it's important to use the correct size of wire and overcurrent protection for the appliance. The appliance manufacturer typically specifies the required wire size and overcurrent protection in the appliance's installation instructions. When installing a dedicated circuit, it's important to consider the specific requirements of the equipment that the circuit will be supplying. Some equipment may require a dedicated neutral wire, while other equipment may require a specific grounding configuration. By understanding the different types of switches and circuits, and by following the NEC guidelines, electricians can ensure that electrical systems are installed safely and correctly. This promotes the safe and efficient operation of electrical equipment and appliances. I will further elaborate on the safety aspects of electrical work, focusing on grounding, bonding, and overcurrent protection. Grounding is a critical safety measure that provides a path for fault current to return to the source, tripping the circuit breaker and preventing electrical shock hazards. A properly grounded electrical system ensures that metal parts of appliances and equipment are at the same electrical potential as the earth, minimizing the risk of electrical shock. The NEC provides detailed requirements for grounding electrical systems, including the type of grounding electrode that must be used, the size of the grounding conductor, and the location of the grounding connections. A grounding electrode is a metal rod, pipe, or plate that is buried in the earth and connected to the electrical system. The grounding electrode provides a low resistance path for fault current to flow back to the source. The size of the grounding conductor depends on the size of the service entrance conductors. The larger the service entrance conductors, the larger the grounding conductor must be. The grounding connections must be made in a secure and reliable manner, using approved connectors and methods. Bonding is another important safety measure that connects all metal parts of an electrical system together, creating a common electrical potential. Bonding ensures that if a fault occurs, the fault current will have a low impedance path to return to the source, tripping the circuit breaker and preventing electrical shock hazards. The NEC provides detailed requirements for bonding electrical systems, including the type of bonding conductors that must be used, the size of the bonding conductors, and the location of the bonding connections. Bonding conductors are typically made of copper or aluminum, and they must be sized according to the size of the circuit conductors. The bonding connections must be made in a secure and reliable manner, using approved connectors and methods. Overcurrent protection is a safety measure that protects electrical circuits from overloads and short circuits. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current if it exceeds a safe level. The NEC provides detailed requirements for overcurrent protection, including the type of overcurrent protection devices that must be used, the size of the overcurrent protection devices, and the location of the overcurrent protection devices. Circuit breakers are automatic overcurrent protection devices that can be reset after they have tripped. Fuses are one-time overcurrent protection devices that must be replaced after they have blown. The size of the overcurrent protection devices must be matched to the size of the circuit conductors. The overcurrent protection devices must be located in an accessible location, and they must be clearly labeled to indicate the circuits that they protect. By understanding the principles of grounding, bonding, and overcurrent protection, and by following the NEC guidelines, electricians can ensure that electrical systems are installed safely and reliably. This protects people and property from electrical hazards and promotes the safe use of electricity. The significance of local codes and inspections cannot be overstated when it comes to electrical work. While the National Electrical Code provides a comprehensive framework for electrical safety, local jurisdictions often adopt and amend the NEC to suit their specific needs and conditions. These local codes may address unique environmental factors, population densities, or specific concerns within the community. It's crucial for electricians and contractors to be familiar with and adhere to the local codes in addition to the NEC. Local building inspectors play a vital role in ensuring compliance with both the NEC and local codes. These inspectors review electrical plans, conduct on-site inspections, and verify that electrical work is performed according to the applicable standards. They may identify potential hazards or code violations and require corrective actions to be taken before the electrical system is approved for use. The inspection process helps to ensure the safety and reliability of electrical installations, protecting occupants from electrical shock, fire, and other hazards. To navigate the local code and inspection process effectively, it's advisable to establish a good working relationship with the local building department. Attend training sessions or workshops offered by the building department to stay up to date on the latest code changes and interpretations. Submit electrical plans for review well in advance of starting work to identify any potential issues and avoid costly rework later on. Be prepared to answer questions and provide documentation to demonstrate compliance with the applicable codes. During inspections, be cooperative and address any concerns raised by the inspector promptly and professionally. By working collaboratively with the local building department, electricians can ensure that their electrical work meets the required standards and is approved for use in a timely manner. Moreover, remember that the local codes and inspection process are designed to protect the public and promote electrical safety. By complying with these requirements, electricians contribute to the overall well-being of the community and help to prevent electrical accidents. Finally, always keep in mind that electrical work is a regulated trade, and it's essential to be properly licensed and insured to perform electrical work legally and safely. Licensing requirements vary by jurisdiction, but typically involve passing an exam and completing a certain amount of on-the-job training. Insurance provides financial protection in case of accidents or damages caused by electrical work. By maintaining the proper credentials and insurance coverage, electricians demonstrate their commitment to professionalism and safety. Let's now turn to the critical aspects of electrical materials and tools, emphasizing their proper selection, use, and maintenance. Choosing the right electrical materials is essential for ensuring the safety, reliability, and longevity of electrical installations. The NEC specifies the types of materials that are approved for use in different applications, and it's crucial to select materials that meet these requirements. For example, the type of wire used for a circuit must be appropriate for the voltage, current, and environmental conditions. Likewise, the electrical boxes, conduits, and fittings must be suitable for the intended use and location. When selecting electrical materials, consider the following factors: the ampacity of the wire, which is the maximum amount of current that the wire can safely carry; the voltage rating of the wire, which is the maximum voltage that the wire can withstand; the environmental conditions, such as temperature, moisture, and exposure to chemicals; the listing and labeling of the materials, which indicates that they have been tested and approved by a recognized testing laboratory. Using the correct tools is also essential for performing electrical work safely and efficiently. Electricians use a variety of tools, including wire strippers, pliers, screwdrivers, voltage testers, and conduit benders. It's important to choose high-quality tools that are designed for the specific tasks that you will be performing. When using electrical tools, follow these safety precautions. Always wear safety glasses to protect your eyes from flying debris. Use insulated tools when working on energized circuits. Keep your tools clean and in good working order. Inspect your tools regularly for damage and replace them if necessary. Never use a tool for a purpose for which it was not intended. In addition to using the correct tools, it's also important to maintain them properly. Clean your tools regularly to remove dirt, grease, and other contaminants. Lubricate moving parts to keep them working smoothly. Store your tools in a dry place to prevent rust and corrosion. Sharpen cutting tools regularly to keep them performing at their best. By selecting the right electrical materials and tools, and by using and maintaining them properly, electricians can ensure that their work is safe, efficient, and reliable. This contributes to the overall quality and safety of electrical installations. I will now expand upon the importance of documentation and record keeping in electrical work, emphasizing the role it plays in safety, maintenance, and future modifications. Accurate documentation and record keeping are essential for maintaining a safe and reliable electrical system. These records provide a valuable resource for troubleshooting problems, performing maintenance, and making future modifications to the electrical system. There are several types of documentation that are commonly used in electrical work, including electrical plans, wiring diagrams, panel schedules, and inspection reports. The electrical plans are detailed drawings that show the layout of the electrical system, including the location of wiring, devices, and equipment. Wiring diagrams show the connections between the various components of the electrical system. Panel schedules list the circuits in each electrical panel, along with the size of the circuit breakers and the loads that are connected to each circuit. Inspection reports document the results of electrical inspections, including any code violations or safety concerns that were identified. These documents should be kept at a safe and accessible location, such as a file cabinet or a computer database. They should be organized in a clear and consistent manner so that they can be easily retrieved when needed. In addition to these formal documents, it's also important to keep records of any modifications or repairs that are made to the electrical system. These records should include the date of the work, a description of the work that was performed, and the name of the electrician who performed the work. This information can be invaluable when troubleshooting problems or making future modifications to the electrical system. Furthermore, accurate documentation and record keeping are essential for complying with electrical codes and regulations. Electrical inspectors often require documentation to verify that electrical work has been performed in accordance with the applicable codes. Maintaining accurate records can help to avoid costly fines or delays. In conclusion, documentation and record keeping are an integral part of electrical work. By maintaining accurate and complete records, electricians can ensure the safety, reliability, and compliance of electrical systems. I will now elaborate on the significance of continuous professional development in the field of electrical work, emphasizing the need to stay updated with the latest technologies, codes, and best practices. The electrical industry is constantly evolving, with new technologies, materials, and methods being introduced on a regular basis. It's essential for electricians to stay up to date with these changes to remain competent and competitive in their field. Continuous professional development can take many forms, including attending training courses, reading trade publications, participating in online forums, and earning certifications. Training courses can provide electricians with hands-on experience and in-depth knowledge of specific topics, such as motor control, programmable logic controllers, or renewable energy systems. Trade publications such as Electrical Construction and Maintenance magazine provide electricians with the latest news, product reviews, and technical articles. Online forums offer a platform for electricians to share information, ask questions, and learn from their peers. Certifications, such as the Certified Electrician designation, demonstrate that an electrician has met a certain level of knowledge and experience. Engaging in continuous professional development not only enhances an electrician's skills and knowledge, but it also improves their job prospects and earning potential. Employers are increasingly seeking electricians who are up to date with the latest technologies and who possess advanced skills. In addition to enhancing their skills and knowledge, continuous professional development also helps electricians to stay safe on the job. By learning about new safety practices and procedures, electricians can reduce their risk of accidents and injuries. Moreover, continuous professional development helps electricians to maintain their licenses and certifications. Many jurisdictions require electricians to complete continuing education courses to renew their licenses. Finally, continuous professional development demonstrates an electrician's commitment to professionalism and excellence. By investing in their own education and training, electricians show that they are dedicated to providing their customers with the best possible service. In summary, continuous professional development is essential for success in the electrical industry. By staying up to date with the latest technologies, codes, and best practices, electricians can enhance their skills, improve their job prospects, and stay safe on the job.